Hello everyone, welcome to Olsen Cafe. Right, now we are going to move into the next section, all right, to know how to find the ratio of two areas. And before we jump into solving problems involving vectors. All right, so in this particular section, right, the question usually will prompt you to find the ratio of two areas. All right, so there are a couple of ways of doing it. So the very first method is when the two triangles are similar. So as you can see from here, in this case, right, in this question, all right, you can see that the two triangles are similar. And how do we know that the two triangles are similar? And usually what you will see in the question, it will be, the question usually will prompt you and to say that there are two parallel lines. All right, but in this case, since that the questions are given that these two triangles are similar, so therefore we can straight away apply what we already learned in similar triangles. So another things to take note is ratio, all right, of units. So over here we see that EC is equals to 3 times of AE. So which means if we write in terms of ratio, I know that AE is equals to 1 unit, whereas EC is equals to 3 units. So as we can recall, based on what we learned in ratio, and we will know that the ratio of area is equals to square ratio of the sides. So given square ratio of the sides, and what are the sides that we are talking about? We are talking about ratio of AE and EC. All right, so with this, hence, I know that the ratio here of the smaller triangle is 1, and then the triangle CDE, it is 3 units. So therefore, I put in place here, then I square this, and I have ratio equals to 1:9. So this is the most basic of finding the ratio of two areas, all right, by using similar triangles. Now, so the other types of questions that you will see, all right, is triangles with common height. Now, this is the type of questions whereby you actually learned it in primary school already, all right? So basically over here, the two triangles that you see, all right, is you will see triangle ABF, which is given here. So you see triangle ABF, and then the other triangle that you see is given as triangle BFC. So triangle BFC is given here. So when you take a look at these two triangles, all right, you must be able to identify the common height. Now, so where is the common height over here? So the common height that we can see is from the highest point, which is B over here, is a common point. So I draw a perpendicular line down. So this will give us the perpendicular height. Yeah, so if you take a look at the highest point, can you see B is actually the common point here, right? The highest point. So this is number one, all right, whereby you must be able to identify the common height. Then the next thing that we will want to pay attention to, which is given ratio. So you can see the ratio is here, is 4 times of AF, all right, is equals to AC. So which means if I translate it into the ratio on the diagram, so what I'm going to have is AC is 4 times of AF. So that means AF here is 1 unit. All right, so if AC total here is 4 units, so therefore this means that FC that I have here for the yellow triangle, it is 3 units. Now, so once I have all this knowledge in place, it's time to apply what we already have. So that means to find area of triangle ABF. So let's recall is half times base. In this case, the base here is AF, which is here. All right, this is the base AF, and then times the height. So let me use a different color so you can see. So this one is height. Then with this, I will also have area of triangle BFC. So I have half times, then the base now is FC. All right, and times the common height. So once I have this, you notice that all I get now, it will be equals to AF over FC. All right, and what is the ratio of AF over FC, which is over here? All right, AF over FC, which is what you can see, AF is 1, and then FC is equal to 3 units. So therefore, the ratio give is 1:3. All right, it's 1/3. All right, so basically what you see here is all the common, all right, value, right, get to cancel away. All right, so that will be the second type of the questions, all right, triangle with common height. All right, so okay, let's move on to practice what we have learned over here. Now, so in any questions, all right, given this one, all right, when the question asks you to find the ratio of the two triangles, the first thing that you will want to ask yourself is, all right, the first question that you may want to ask yourself is, are the two triangles similar? Yeah, so over here, if you see that the two triangles do not have parallel lines, then therefore you know that, oh, they are not similar triangles at all. So therefore I can't use similar triangles over here. Yeah, so what do we have? So you take a look at triangle PTQ. So let me use different ink to demo. So triangle PTQ, so I have this one here, triangle PTQ. So I have this. Then the other triangle that I have, I use another one, which is PQR. So PQR, if I'm going to draw the triangle, so I have this one here, P, Q, and R. So I'm actually looking at the blue triangles here. Yeah. So at one look now, okay, you will see that these two triangles actually share a common height. So where is the common height? So the common height is actually from the common point here, the highest point, which is Q. So if I'm going to draw the common height from Q, I will draw the perpendicular line down. All right, perpendicular line to PR. So with this, I am able to identify the common height. Yeah. So now the next thing is we have already learned, if I want to make use of common height to find the ratio of area, so I must be able to know what is the ratio. So what is the ratio given over here? All right, the ratio now that I have is PT. All right, PT and TR. So some of you may not be able to identify the ratio so straight away. So a simple trick that we can do is we just write in fraction. Maybe it helps you to see. So I have PT over TR. So this in turn give us 2/3. So which means I know that PT here, the ratio is 2 units, and TR here will take up 3 units. So this is basically apply what we have learned earlier on in primary school. So now combining all this that I know, so to find area of triangle PTQ, so this will give me half times, if you look at PTQ, so the base is actually PT, and then I have the common height, which is H. Then if I look at area of triangle PQR now, so triangle PQR, so again, I apply this half time base. In this case, the base that I have is the big triangle in blue, so which is PR. And I also have the common height, which is H. So given this, H, cancel. So therefore, what is left is PT over PR. So, and what is the ratio of PT over PR? PT, it is quite clear, it is 2 units. And what is PR? So if you look at PR here, PR is PT plus TR. So therefore 2 plus 3, therefore I have is 5. Yeah, so this is another example of how we can actually find ratio of area by using common height. Now let's take a look at the other question. Okay, now so this question look a little bit more complex than the earlier one already. Yeah, so let's see how we can apply what we already know. So let's take a look at the information that we have. Right, so the first information that we are given, all right, is QR is equals to 4 times of QS. So if I'm going to apply this, so which means I am able to know that, oops, sorry. So let me go and write down. Sorry, let me go and write down what I have on the ratio here. So which means I know that QR, yeah, QR is equals to 4 times of QS. So that means QS is 1 unit. And then if QS is equals to 1 unit, and therefore QR will take up to be 4 units. So therefore SR is equals to 3 units. Yep. So now I move on to the next info. The next info that I have here, right, it is 5 times of QX equals to 2 times of QT. So with this, let me put everything together. So 5 times of QX. So that means this one is 2 units. So that means I will see QX with this and then QT with this. Yeah, so that's another way to look at it. So I have QX is 2 and then therefore QT is 5 units. So that means this work out to be, this one is 3. One last one. All right, one last ratio that we have here. Let me use green. All right, so I have this here. So now SP is equal to 5 times of SX. So with this, that means now what I have will be SX is 1 unit. All right, and then PX is actually equals to 4 units. Yeah, so that is how I put all the information together. And of course, the last info that is given to you is T is the midpoint of PR. So when this is given, T is the midpoint of PR. So that means I know that the ratio of the length between PT and TR is actually 1:1. So this information will come in very handy later on. All right, so once we understand the diagram, right, we are ready to find the area. Okay, so let's see what is the area that we have now. I want triangle PQX. Now, so PQX, what we have here is this. Let's look at the triangle. I have triangle PQX. So I have PQX, which is here. Okay, and then the next one is PQT. So given PQT, so I'm going to use another color. So PQT is this one here. Okay, so I have this PQT. So we take a look at these two triangles. So again, if you ask the questions, well, are these two triangles similar? So answer is no, they are not similar. Yeah. So if they are not similar, then therefore the next question is, do they have the common height? Answer is yes. So the common height here is this. Right? So once I'm able to identify the common height, I am ready to find the ratio. So in this case, all right, the ratio that I have here, I'm going to apply, that will be half times, the ratio will be PX, and then times height. And then the next one will be half times the big triangle in blue. So the ratio below the will be QT. The base is QT. So I have this. So by putting all this together again, so what you see is the ratio of the area is simply the ratio of the two bases. Yeah, so as a ratio of the two bases, I know that PX, oh sorry, it's not PX. All right, it should be QX, pardon me. All right, so this one is actually QX. Okay, so it's actually QX over QT. So with this, I know that QX, the ratio is 2, and then QT is equals to 5. So I combine all this together. So I simply know that the ratio is simply just equals to 2 over 5. Yeah, so that's how you get the ratio for part A. Now let's look at the ratio for part B. Now, so let's erase off all this. Okay, maybe, yeah, I think we'll just leave all this first. So I want to find area of triangle PQX, which is one in yellow, and triangle PQR. Now you notice if I'm going to use another color, let's see now, I shall use green. So I have PQR. So now PQR is this one in green, PQR. All right. Now it's a bigger triangle. So if you see, all right, between the triangle in yellow together with the triangle in green, PQR, you will notice that there is no direct link between these two triangles. So therefore, how can we find the ratio between these two? Yeah. So one way to take a look is, one way to solve this is by looking for a third party. I call it a third party. So that means I need to look out for a relationship. So from here, right, what I can see is that there is a triangle PQT in blue. So you notice that the triangle PQT and PQR, are they related? They are, because if you see, right, T is the midpoint of PR. So if T is the midpoint of PR, that means I can say that the ratio of the area of the triangle in green, the bigger triangle, right, it is actually 2 times of the area of triangle PQT, which is in blue. So combining all this information that I have, I'm going to put them together. All right, so this is what I'm going to have. Yeah, so putting all this together, PQX, I know that it is equals to area. Let me write this down first. PQX, then divide by, and I know that area of triangle PQR is equals to 2 times area of triangle PQT. So when you take a look at this, right, you will notice that this, isn't it, is actually the result from part A, right? Area of triangle PQX and triangle PQT. So when I combine these together, so therefore I will have a half and multiply by the ratio of what I have from part A. So combining these two, I simplify, I will get the final ratio for area of triangle PQX and triangle PQR. Yeah. So for questions like this, for part B, this kind of questions, right, what you do need to look out for is you look out for the third party. So in this case, triangle PQT over here, it is what I call the third party. So basically, this third party is actually linked, or is the link between triangle PQX and triangle PQR. So hopefully with this video tutorial help you to understand a little bit more about how to find the ratio. So the basic will be 2 methods. Number 1, let's recall, that is to use similar triangles concept to find the ratio of the 2 triangles, which is what we have seen in the very first example. And then the other one, right, the second method will be by identifying the common height. All right, identify the common height between the 2 triangles, as you can see from here, the one in yellow and in blue. Then if, right, the triangles are not related at all, neither they are similar triangles nor they have a common height, then what we do is we look up for the third party. All right, so hopefully with this, all right, I help you to understand a little bit better. So do look out for the next video that I'm going to demo to you and demonstrate to you how can we solve a typical long questions involving vectors. All right, so I see you in the next video. Okay, bye.